Okay, so next one, number 4. We've got 2007 4H. So the other one was 3H. Same deal, same formula sheet, same stuff. Should be familiar with this now. Okay, so we've got this one right here. This is a calculated job. 5.9 5.9, I'll do it in blue, minus 4.3 over 1.3 plus 1.2. Straight into the calculator for this one. 5.9 minus 4.3 over 1.3 plus 1.2 is 16 over 25. Yeah. Is a decimal. It doesn't require you to do it as a decimal, so you might as well leave it as a decimal or a fraction. Both would be fine. Okay. Factorize, as I'm sure everybody remembers, is when you look for a factor in 5x and a factor in 20. So when we factorize something, we're pulling it into two things that multiply together to give the original thing. So looking at that 5x, to factorize that, there's only really one way of doing it. We've got 5 and, well, that's my daughter. I've got 5x and that's my other daughter. The 5x, and so our factors are only 5 and x. 20, the factors that we've got for this one are 1, 2, 4, 5, 10, and 20. So I can see that I've got a factor in both of them. Yeah, that's the same, 5. So what I can do is I can pull a 5 out of both terms and then draw brackets. Okay, now if we were to multiply this out, we'd get 5 times x and 5 times minus 4, because we've got that minus there. So the answer here is going to be 5 times x minus 4. Factorize y squared plus 6y, same thing. So my factors of y are y times y, and the other one is 6 times y. The common factor is y, so I'm going to pull that out and get y times y plus 6. I can always check my answers by multiplying out these brackets. If I multiply this out, I get y times y, which is y squared, and I get plus 6 times y, which is 6y. Now remember also, for questions like this, it's not saying what is y or solve an equation. These are just expressions. Okay, very important to remember. Question 3. Right, £1 is 2.61 New Zealand dollars, not anymore, and £1 is 1.45 euros. Convert 630 New Zealand dollars to euros. Okay, so if I, well, what do I want to do? Well, what I can do is I can say, well, £1 is 2.61. So how many pounds have I got? Well, oops. If I do 630 New Zealand dollars divided by 2.61, that will tell me the number of pounds I have. So I'm just going to do that on my calculator. 630 divided by 2.61, and that's 7,000 over 29. Yay, lovely. About 241 pounds. Now, so that's, if I've got 200, let's say, call it 241.38 pounds. Okay, so if I've got that many, then I've got to say, well, how many euros is that? Well, £1 is 1.45. So if I've got 240 of them, 241 of them, I'm just going to have 241.38 times 1.45. Okay. And so that gives me times 1.45 is 350. So that's my answer. For a question like this as well, I've got a good sense that my answer is correct simply because it's a round number. There's nothing in the question about significant figures or decimal places, so it must go to a regular, normal, non-decimal number. Okay, next one. Describe fully the single transformation which maps triangle T onto triangle U. Okay, well, I can see that it's a reflection down that line. Yeah, this is quite an easy transformation question. I think the rotation ones are definitely the hardest. Remember, we've got three different types of transformation. We've got a reflection, we've got a translation. Translation must be shown in vector form, where this is the left-right movement and this is the up-down movement. Positive is right, negative is left, and up, down. Positive is up, negative is down. And there's also rotation. So for a reflection, this question here is out of 2 marks. So reflection gives you 1 mark, and the other mark is going to be what line is it reflected in. So I can see that it's reflected in as I drew that line on the thing. Now we have to actually write the equation of that line. The equation of that line is x equals 4, because remember what a graph is, or a line on our plane is. Any point that I choose on this line, x is going to be 4. So that point there would be 4, 1. That point there is 4, 2, 4, 3. 4.5, sorry, 4, 3.5. Any point we choose is going to be x has got to equal 4. So that's what we do. We choose that line. So it's going to be a reflection in the line x equals 4. Okay. That's where the 2 marks come from. You get 1 for reflection, 1 for whatever line it's in. For translation, you get 1 mark for saying what translation it is, and then it's usually either maybe 1 or 2 other marks, because you have to get the amount that it's been translated by, so the amount that it's moved by, but you have to give it in vector form. Okay, if you don't write it like that, for example, if I had if this were the question and it was describe the transformation, it's gone up by 1. So this answer would be a translation in the vector 0, 1. Okay. Rotation, you need 1 mark for rotation. Second mark is always, is it clockwise or anti-clockwise? And finally, you have to have the point of rotation, which is always quite difficult to find. Don't worry about that too much, I wouldn't. All right, next question. In 2004, the ratio of number of planes in Air China's fleet to the number of planes in Malaysian Airlines fleet was 6 to 7. Okay, there are 72 planes in Air China's fleet. Work out the number of planes in Malaysian Airlines fleet. Okay, so first of all, I can see that China's not going to have as many as Malaysian Airlines, so that gives me just a little bit of an idea of where I'm going here. So what am I going to work out? Okay, well, 72 is going to be some multiple of 6. Okay, I don't know what. So I'm going to work out 72, oops, not 77, 72 divided by 6, and that equals 12. Now, it doesn't necessarily always have to be a round number. It could be that there were 75 planes, but we've still got the same thing, which would be 12.5, same kind of approach. So this is how many times that ratio goes into 72, right? At its simplest, there is only 6 planes, right? And of course, anything above 6 is going to be a multiple of 6. So if we know that the multiple that we're using here is 12, all we need to do then is to say, well, if we've got 7 as the simplest number of planes that Malaysian Airlines has, we can times by 12 to get 84 planes. So now my ratio is 72 to 84. Okay, and we can just check our answers, because if we've got a ratio, we can always divide by a common factor. So here I could divide by 12, which is exactly what I just did, and get 6 to 7. So work out the number of planes in Malaysian Airlines fleet is 84. Right, next question. A, B, C, D are parallel straight lines. P, Q, and PR are straight lines. Find the value of X. Okay, so this is just testing your understanding and if you can remember what different angles are. Hopefully you should be able to see that you should remember that this angle here is going to be 180 minus 57. 180 minus 57 is 1, 2, 3. 1, 2, 3. And that, for example, this angle here is also going to be 180 minus something, 180 minus 109. Remember, points angles at a point on a straight line add up to 180 always. So that's going to be 71. Okay, and then it's testing your understanding of parallel lines. So, I mean, if you look at these two up here, okay, I can also do the same thing with this line here. That's 180 minus, if I look at this line, then I've got 180 minus that angle is going to be that angle, which just happens to be exactly the same as that angle, 57 degrees, right? Now, because these lines are parallel, A, B, and C, D, then I know that that situation there is exactly the same as that situation, as that one up there. So I can work it out, no problem. I can see that it's just going to be 57 degrees. That's going to be 57, and that's going to be 57 as well, 57 degrees. Now, that's a long way of answering the question for part 2 here, because what it's asking you is, do you know the word alternate angles? Alternate angles in parallel lines. Okay, we've got Z angles are the same, corresponding angles or F angles, and complementary angles. Alternate, corresponding, I think this is what they're called, and complementary angles. Okay, also named Z angles, F angles, and C angles. Even if you mention that, you probably get the marks as well. Find out the value of Y. Okay, same thing. I'm going to say 180 minus 109 equals 71, and then Y equals 71 because they are corresponding angles. 71. Next question. There are 4 grades of egg. The table shows how many eggs of each grade were laid by a hen last year. Who comes up with these things? Right. In the first 4 months of this year, the hen laid 60 eggs. Work out an estimate for the number of extra large eggs the hen laid in these 4 months. Okay, so if you look at all of these, this is going to give us a prediction, a probability of the different sizes of eggs that a hen laid. So if we say take 1 egg at random, what's the probability that it's going to be extra large or medium or small? Okay, well, the total number of eggs from last year is going to be 55 plus 48 plus 35 plus 12, which is 150. So if I choose any one of these eggs at random, the probability is going to be 55 over 150 for that one, 48 over 150, 35 over 150, and 12 over 150. So I'll work those out on my calculator really quickly. 55 over 150 is about 0.367. 48 over 150 is 0.32. 35 over 150 is 0.233. And 12 over 150 is 0.08. Okay, so the probability that I choose an extra large egg out of all of those 150 eggs would be 0.367. The probability that I choose a large egg would be 0.32, 0.233, and 0.08 accordingly. Okay, so those are the probabilities that an egg gets laid by this hen. This is the probability distribution. So it says, work out an estimate for the number of large eggs the hen laid in these 4 months. Well, because this is an estimate, we don't know exactly, but we do know that the probability from last year, of an extra large egg, was 0.367, or 55 over 150. So we expect 0.367, or 55 over 150, of those 60 eggs to be extra large eggs. So I'm going to do 55 over 150 times 60. 55 over 150 times 60 equals 22. So my answer here is 22. It might be right, it might be wrong, but it's a good estimate. The table shows below how the grade of an egg is related to its weight. Okay, work out an estimate for the total weight of 48 large eggs and 35 medium eggs. Okay, well, we don't know exactly how heavy these extra large eggs are. We don't know. We don't know how heavy the large eggs are. We don't know how heavy the medium eggs are. We don't know how heavy the small ones are, but we know roughly, right? We know that it's somewhere between there and there, and somewhere between there and there, somewhere between 63 and 73, and somewhere between 53 and 63. We don't know exactly how heavy they are, though, but what we can do is we can say, well, if you had to choose one number to represent these large eggs, well, I would choose halfway between the two. And I can work that out because 63 to 73 is plus 10. So if I want halfway, then I'm just going to plus 5. So 63 plus 5 is 68. So I'm going to let 68 represent the weight of my large eggs, and I'm going to let 58 represent the weight of my medium eggs. Yeah? Okay, so then all we need to do is just say, okay, well, 48 large, so 48 times 68, plus 35 times 58, And that's just a calculator job, which is 48 times 68 plus 35 times 58. That's 5,294. 5,294 grams. Jody wants to use the information in the table to work out an estimate for the total weight of all the eggs laid by the hen last year. Now, this should be a question that you were thinking, how can you know what number would be good to represent that? And how do you know what number would be good to represent the extra large eggs? We don't. We can't estimate the weights of the small and extra large eggs. Okay, right, let's move on. Question 8. We'll do 10 questions today. On the number line, show the inequality -2. X is greater than -2, but less than or equal to 3. So hopefully you're familiar with this notation, okay? If I said X is less than 5, that's what that one there means. It means less than. Or X is greater than 5. This thing here, X is less than 5, so 4 was fine. 4.5 is fine, -500 is fine. Similarly here, 6 is fine, 72 is fine, 6.000001 is fine because it's, oh, sorry, 5.000001 is okay because it's greater than 5. Now, if it's X is less than or equal to, that's what that little other line means, 5, then 5 is included in our numbers. So we've got all the numbers up here as well, so anything less than 5, but it also includes 5. And similarly, X is greater than or equal to 5, it's all of those numbers up there and 5 as well. So here what we've got is an inequality that's got two inequalities in both sides. And it says that X is less than or equal to 3. Okay, now it's less than or equal to, we represent that with a dot. And it says, show the inequality. Well, this dot represents what X is. So X can equal 3. But it also can represent things less than 3. Okay, so it represents everything less than 3, and it goes all the way down to how far? You guessed it, -2. But -2 is just less than, sorry, it's greater than -2, so not equal to. So for that one there, we use a circle like that. So equal to or less than, we use a circle, a filled in dot, and greater than or less than, we use an empty circle. Okay. It says n is an integer, a whole number. And it says write down all the possible values of n which satisfy the inequality, which means which work in the inequality this. So I know n is greater than or equal to -1, so -1 is okay. 0 is fine, 1 is okay, 2 is okay, 3 is okay, 4 is not okay because n must be less than 4, not just less than or equal to. So you've got to make sure that you've got to be really, really careful with those equal to or less than or less than. Okay. Use a ruler and compass to construct the bisector of angle ABC. You must show all of your construction lines. Okay, so I'm going to have to just do this roughly. But what I would do is I would put the point of my compass there, and I would put a line here, and I would draw kind of like a circle like that. And then, without changing the compass, I would then put my compass point there. So first put the compass point there, then draw the line, then put the compass point there, and without changing it, and you should get something like an R. Oh, no, not quite right like that. See if I can get this quite right. About like that. Oops. Something like that. And then I'm going to do the same. I'm going to put the number 4. I'm going to put the compass point there, and I'm going to do the same thing. Get kind of like an arc, a little bit of an arc there. And then what I can do is I can use a ruler, and I can join point B to there, and I can do that with a straight line. And that's what a bisector means. Bi means double. So bisect is cut it in half in 2 exact pieces. So what we're doing is we're bisecting that angle. Whatever angle that is, let's say it's 60 degrees, that now will be a 30 degree and a 30 degree angle. Next one. Complete the tables for the value of x squared minus 2. Okay. Now I'm going to use my calculator for this. I'm going to what I'm going to do is I'm going to put in, I'm going to put brackets. I'm going to put this value here in my calculator. So what I'm going to do is I'm going to do brackets -3 squared minus 2. Okay, so that should give me -11. Then for this one here, next one, I'm going to do -2. You must use those brackets, otherwise it will not work. Minus 2, which is -6. 0 is going to be -2 because it's 0 squared minus 2. And then the next one, I can just do 1 squared minus 2, which is -1. 2 squared minus 2. Oh, see, I've already gone wrong. This is something that I've done wrong. This is a slip on my part here, because what I did was I put in -3 without the brackets. So you need to make sure that you're getting it in the right place, otherwise it's not going to work. You need to put those brackets in, peeps. If you don't put the brackets in, you get -3. You get -3 squared, which is -9, which you don't want. You want -3 squared. -3 squared is 9. 9 minus 2 is 7. And then here, 4 minus 2 is 2. And then the rest are going to be the same. Okay. And I figured that out when I got to this one right here, because I thought, well, 2 squared is 4 minus 2, which equals 2, and that wasn't the same as this one over here. Now I know that this is a quadratic, and that means it's going to look like a curve. This kind of shape. So it's symmetrical. Yeah. So if it's not coming out symmetrical, chances are something's going wrong. And now I'm going to draw on my grid on my grid. I'm going to start. Doesn't matter where we start. What have we got? 7. Okay, at -3. So got 7, 2, -1, -2, -1, 2, and 7. And then when you're joining these up, you must make sure that you do it freehand. Ooh, and you do it better than me. Go away. Because it's got to be freehand because it needs to be a curve. If you draw it with a straight line, so with a ruler, you will not get the marks. You will lose marks for this. So that's what the end product should look like. And I think that will do. So the next one is, should we do the next one? Yeah, let's just do question 11. 50%, 56% of the students are in school. There are 420. 56% times 420. 56% of the girls, 50% students in schools are girls. There are 420 girls in the school. Look at the number of students in the school. Oh, so it's not actually as easy as I thought, because 0.56, or I read this wrong, 0.56, which is my, if I want to find a percentage or something, times something, that's the total number of schools and girls in the school, right? But I know that that equals 420. So just over half the school girls in a school are is 420. So, well, we've got an unknown here. So what do we usually use? X. And now we've got an equation. So 0.56 times x. To get rid of that, remember what we do? We just divide by 0.56. And we get x equals 420 over 0.56, which equals 420 divided by 0.56 is 750. Okay, so the number of students in the school is 750, and we will leave it there. Thanks for listening. Enjoy the rest of your day.